In the last video, we started talking about the big three, first up with the copy constructor. This time we're talking about the second element, the destructor. Before explaining what exactly the destructor is, I want to talk about why it's necessary. So in our previous code example, we created a simple cube class, which had some aspects such as an edge length, a number of faces, which was a constant 6, and we created an array of strings so that each face had a separate name. What we care about in this example is this array right here. The destructor focuses on dynamic memory, so let's just focus in on that. After properly declaring our cube in the respective .h and .cpp file, we decide to create a cube pointer in our main. But when we run our program with valgrind, which checks for memory leaks, we see that we have definitely lost some memory. Does anyone know why we lost this memory?
I know. We never delete C.
Exactly. We create dynamic memory with the new constructor, but then we never delete it. But there's a problem beyond that. Even when we delete C, we still have the memory leak. So let's review what just happened. We created a cube object and gave it dynamic memory. When we ran the program, we had a memory leak after creating a pointer to it. Even when we called delete, we still had this memory leak. We did everything right, but delete was causing a problem. This means we need to tell the compiler how to delete our custom object. In other words, we need to write a destructor. The destructor is a set of instructions associated with an object that tells the compiler how to remove any dynamic element. The common destructor for every object is just empty. You never have to delete basic information. What you do need to delete is dynamic information. The destructor is always written in that same form. The tilde before the name of the object, followed by parentheses. Our destructors will never have arguments, and there is a reason for that, which we'll see later. In our .cpp file, we must implement the destructor ourselves. And then when we run our main again, we see that we have no more leaks. Are there any questions?
When do we have to call the destructor?
Yeah, so there is a good rule of thumb for when you have to call the destructor. The answer is you never have to do it. The destructor is called in very specific situations. Number one is it's called by the compiler when an automatic variable goes out of scope. Now you can think of an automatic variable as a variable you didn't explicitly create. For instance, if you think of a pointer in a function parameter, you never created that pointer. If there was an integer pointer x in that parameter, you never said x equals new int something. That pointer was instantiated by the compiler, and therefore it will be destroyed by the compiler. You call the destructor indirectly when you call delete. You will have to do this when you create a pointer with the new syntax. It's no different than basic data pointers. Whenever you call new, you still have to call delete. And to reiterate, the destructor is never called by the user. The only time you will use that tilde object name syntax is when you are defining the destructor. And before we go, I have one more useful tip to make your destructor the most efficient. Here's what we had before with our cube destructor. I want you to take that information and copy it into a helper function, usually called clear. Then when you call the destructor, simply call clear. You did this before with the copy method in the copy constructor, and I promise you'll see why this is useful when we cover the last element of the big three.